Hello students, myself Dr. Vijayalakshmi. In the last class, we studied about nucleophilic addition reactions of aldehydes and ketones. In this video, we will study about some special reactions of aldehydes and ketones. Among that, one is aldol condensation. In this aldol condensation, aldehydes undergo self-addition in presence of dilute base and give condensation product, and that product is called aldol. Or if ketones are there, they also undergo self-addition and product is called ketols. For this reaction, the important one is that aldehydes or ketones should contain alpha hydrogen. It is alpha hydrogen, the functional group. Adjacent to the functional group, the carbon is called alpha carbon, and that carbon vs the hydrogen is called alpha hydrogen. So if aldehydes and ketones which contains this alpha hydrogen, they undergo this reaction. So in presence of a base, they undergo self-addition and gives addition product or condensation product called aldol. For example, acetaldehyde, two molecules of acetaldehyde undergo self-addition, and by removing a mole of water, both are added, and that is called condensation. So in presence of base, that is a dilute NaOH can be used here, and it gives addition product that is called 3-hydroxybutanol, or it is acetaldol. Aldol, which is obtained by acetaldehyde, acetaldol. If a ketone, that is acetone, is taken, two molecules of acetone undergo self-addition in presence of base and gives ketol, 2-hydroxy, 2-methyl, pentane 2-one. Let us see the mechanism of this reaction, how this self-addition takes place. So in presence of base, the reaction takes place. So here base initiates the reaction. In the first step, the nucleophile, that is OH minus ion from the base, it removes a proton from alpha carbon to form carbanion 1. It removes a proton from alpha carbon. So in the acetaldehyde, from CH3, one hydrogen. This is attracted by this, the hydrogen attracted by, or the proton is attracted by this OH minus, and it is removed as H2O. The base takes a proton and forms H2O, and remaining is carbanion. So carbanion 1, because another anion is formed in this reaction. So let us take it as 1, carbanion 1. One hydrogen is removed from this CH3 group. Now this carbanion 1 acts as a nucleophile and attacks the carbonyl carbon of another acetaldehyde. So total 2 molecules of acetaldehyde are reacting here. The anion formed from one acetaldehyde is act as a nucleophile, and it reacts with another one acetaldehyde molecule. So here, when there is a attacking reagent is present, among that C double bond O, the pi electrons are shifted on oxygen. So oxygen becomes negative, carbon becomes positive, and to that carbonyl carbon, this nucleophile will attack, and it gives the addition product here. In that the oxygen is having minus charge. This is anion 2. So formation of anion 2 takes place from the attack of carbon ion, which is generated in the first step. It attacks the carbonyl carbon of another one aldehyde and produces anion 2. In that anion, the negative charge is present on the oxygen. So in the third step, the anion 2, it takes back a proton from this water molecule. This water molecule which is formed in step 1. From that, this anion will take a proton and it becomes OH. So this is called aldol. This product is called aldol and here base is generated back. So this is a 3-step mechanism. In the first step, the base helps for the formation of carb anion by accepting a proton from the alpha carbon. In the second step, the carbon ion formed in the first step is going to attack another molecule of aldehyde, the carbonyl carbon of another molecule of aldehyde, and it produces anion, that is anion 2. Now this anion accepts a proton from water molecule and becomes aldol and base generated back. So this is aldol condensation, one of the important reactions of aldehydes and ketones. So remember here, for this aldol condensation, the aldehydes or the ketones should contain alpha hydrogen. So the aldehydes or ketones which contains alpha hydrogen, when they are treated with dilute base, undergoes self-condensation and gives the product aldol or ketol. Second one is Cannizzarose reaction. In the Cannizzarose reaction, again the condition is same. The aldehydes, 2 molecules of aldehydes treated with base, but the aldehyde here does not have alpha hydrogen. The aldehydes which does not having alpha hydrogen, they when treated with the concentrated alkali, in the aldol condensation just dilute alkali, that is weak alkali, helps for that reaction. But in the Cannizzarose reaction, concentrated alkali is needed. So aldehydes which does not having alpha hydrogen, when treated with concentrated alkali, that may be a NaOH or KOH, undergo mutual oxidation reduction. The same molecule, one molecule undergo oxidation, another molecule undergo reduction. So mutual oxidation reduction forming one molecule of each corresponding alcohol and salt of acid. So for example, formaldehyde is taken. In the formaldehyde, there is no alpha carbon, so no alpha hydrogen is also present. When treated with NaOH, when it is heated with NaOH, it gives one molecule of alcohol and one molecule of sodium formate. The number of carbons in the product are equal to the number of carbons present in the reactant. So in the formaldehyde, it contains only one carbon. So one carbon containing, that is methyl alcohol, is produced, and one carbon containing acid, it's salt, that is formic acid, salt of the formic acid. So sodium formate is formed. Another one example is if aromatic aldehydes are taken, benzaldehyde. So this, the functional group containing carbon, adjacent to that carbon, this is the alpha carbon, there is no hydrogens are present on alpha carbon. So when this benzaldehyde treated with NaOH, two molecules of benzaldehyde undergo mutual oxidation reduction and they forms one molecule of each, that is benzyl alcohol and sodium benzoate. So benzyl alcohol contains the same number of carbons which are present in the benzaldehyde. Let us see the mechanism of this reaction. So again the reaction is catalyzed by the base. So one molecule of aldehyde when reacts with the base OH minus, nucleophilic addition of OH minus on carbonyl group, it gives anion 1. So in presence of a reacting agent, the pi electrons of this carbon and oxygen bond are shifted to oxygen and this OH minus attacks to electron deficient carbon and it gives the addition product, that is anion 1. So when C double bond O, the pi electrons of C double bond O are shifted to oxygen, oxygen gets a negative charge and this OH minus attacks to this carbon, so carbon oxygen new bond is formed. This is called anion 1. Anion 1 reacts with another molecule of aldehyde. So anion 1, it transfers a proton to another molecule of aldehyde to yield an acid and alkoxide ion. So this is anion 1. It approaches another molecule of aldehyde. So again in the presence of attacking reagent, the pi electrons are shifted to electronegative oxygen so that oxygen gets the negative charge. CH is there. From this anion, the negative charge on oxygen is given to carbon oxygen bond. So C double bond O is formed. In the same time, it gives that hydrogen. CH bond electrons are given to hydrogen so that this H minus will going to attack this C plus so that it forms a alkoxide ion. This aldehyde is converted into alkoxide ion and this anion 1 is converted into carboxylic acid. In the next step, in presence of alkali, acid forms salt with Na plus and proton exchanges to alkoxide ion. So this is the acid formed in the first step that reacts with the base because the medium of the reaction is strong base, concentrated base, the reaction is taking place. So when this acid, it reacts with NaOH, that is Na plus ions from the base and it forms salt of acid. So acid plus base reacts and gives salt. Sodium salt of the acid is formed and liberates H plus. That H plus reacts with alkoxide ion and gives alcohol. So when aldehyde is treated with the sodium hydroxide, it gives one molecule of corresponding alcohol and one molecule of salt of the corresponding acid. For this Cannizzarose reaction, aldehydes which undergo this reaction they are having no alpha hydrogen. Aldol condensation and Cannizzarose reaction both are having the same conditions, aldehyde treated with base. But the difference is in the aldol condensation weak base is used in the Cannizzarose reaction, strong base is used. In the not a weak base, dilute base is used in aldol condensation and concentrated base is used in Cannizzarose reaction. In the aldol condensation, aldehydes which having alpha hydrogen are going to react. In Cannizzarose reaction, the aldehydes which does not have alpha hydrogen, they are going to react. Let us see another one, Claisen-Smith reaction. In this reaction, benzaldehyde condenses with aliphatic aldehyde or methyl ketones in presence of dilute alkali at room temperature to form unsaturated aldehydes or ketones. So benzaldehyde condenses with aliphatic aldehyde. Again, two aldehydes are present here. In presence of dilute alkali, the condition is same like the aldol condensation. In the aldol condensation also, two molecules of aldehyde are going to react in presence of weak base. Here also, two molecules of aldehyde are going to react in presence of dilute alkali. But the thing is, both are different aldehydes. Here self-condensation is not taking place in between two different aldehydes. So one is benzaldehyde aromatic aldehyde, another one is aliphatic aldehyde or methyl ketones in presence of dilute alkali. At room temperature, they form unsaturated aldehydes or ketones. So this type of the reaction is called mixed aldol condensation, or it is also called Claisen-Smith condensation. So in this condensation, one molecule of benzaldehyde aromatic aldehyde react with another molecule of acetaldehyde. Remember here benzaldehyde does not have alpha hydrogen. Acetaldehyde having alpha hydrogen. So one is aliphatic aldehyde, another one is aromatic aldehyde. In presence of dilute base, the condensation between the two molecules takes place and it gives the product like aldol. But we are heating the reaction mixture, so that product will loses a mole of water molecule and gives alpha beta unsaturated acids. So this is the functional group. Adjacent to that alpha carbon, this is beta carbon. In between alpha and beta unsaturation, that is double bond is present. So these are called alpha beta unsaturated aldehydes. Or if ketones are taken, then alpha beta unsaturated ketones are produced. In this reaction, the example is cinnamaldehyde, which is having unsaturation at alpha and beta carbons. Let us see the mechanism of this reaction. Initially, the acetaldehyde that reacts with the base. This base takes a proton from the acetaldehyde and anion is formed. So carb anion 1 is formed in first step. So like that in the aldol condensation, this anion 1 is going to attack the benzaldehyde, carbonyl carbon of benzaldehyde. This anion 1 acts as a nucleophile. So in presence of nucleophile, the pi electrons of carbonyl carbon are shifted to oxygen because which is more electronegative, and carbon C becomes plus. To that carbocation, a nucleophile will attack and it gives anion 2. In the anion 2, the negative charge is obtained on the oxygen. This anion 2 In the next step, further step, that anion 2 at the alpha carbon, so adjacent to this functional group, this is called alpha carbon. One of the hydrogen from the alpha carbon is transferred. So this O minus, it will take a proton from this water and becomes OH. But when the reaction is heating, we are heating that reaction. So in that temperature, the proton from the alpha carbon, so adjacent to this functional group, this is alpha carbon, a proton, that is hydrogen from the alpha carbon, CH bond electrons are given to this carbon-carbon, so that carbon-carbon new double bond is formed. This OH bond electrons are given to oxygen, so OH minus and H plus are removed as H2O, and new carbon-carbon double bond is formed between alpha and beta carbon. So it produces alpha beta unsaturated aldehydes. Here cinnamaldehyde is obtained from the reaction between benzaldehyde and acetic acid. So here two different aldehydes are taken. The reaction condition is same like the aldol condensation, but the difference is in the aldol condensation, self condensation means two same molecules are undergo condensation in presence of dilute base. But in the mixed aldol condensation, one molecule of benzaldehyde, that is aromatic as aldehyde, which does not have alpha hydrogen, and one molecule of aliphatic aldehyde, which is having alpha hydrogen, both are going to they are reacting with dilute base and gives the condensation product, that is called alpha beta unsaturated aldehyde. So in this video we studied three mechanisms. Just see the difference between the three mechanisms where we are using the where we are using dilute base, where we are using concentrated bases. Alpha hydrogen present, then which reaction is going to take place. So if no alpha hydrogen, then which compound is obtained. Just go through that and you will get that reactions. So another further reactions we'll see in the next video. Thank you, students.